do last time. But remember today we're doing DNA and fingerprints. So if everybody has like their tape and their paper and their preferably non-mechanical pencil, that we'll just get started into the mini lesson. We're going to go over homework at the end, but here we go. Okay, so today we're going to learn a little bit about genetics. So last week I said that forensics combines all kinds of science, and one of them is biology. So biology is the study of life, and we're going to learn about how we can use biology and consequently genetics to help determine cases. Although I think you guys are already getting the idea. So in genetics is what is determining what your body looks like. For example, my face is a product of my genetics. So we're going to learn about structures in you called chromosomes. Chromosomes. Okay. And these are structures that exist in each of your cells. Your cells. What are your cells? Well, they are the basic building block of life. So they're these like tiny little things. You can't even see them. And they make up you and all living things, right? So for example, my skin, I have skin cells. These are all skin cells. You can't see them because they all make one big thing and they're tiny, but they are there. And your chromosomes are things that determine what you look like, and they are passed down from parent to offspring. So they're these like little squiggly things that are in your cells, and they tell you how to build another one of yourself, basically. And humans have a total of 23 pairs of chromosomes. 23 pairs of chromosomes. So in total, you have 46 separate chromosomes in each of your cells. And those chromosomes are telling your body how to do. And the 23rd pair of chromosomes is called the sex chromosomes because they decide what sex you are born as. So for example, are you male or female? And I don't know if we're going to get too deep into that. So as I said, half your chromosomes come from one parent and half from the other. We're not going to go too deep into this as well, but basically the way it works is that in both of your parents, like they have cells that are split in half. So the pairs of chromosomes are both like kind of like torn apart. So each of these special cells has 23 chromosomes. So mom, one from your dad, and they form together to make you, first cell. And since I'll answer this. So for example, let's say the first 23 is like your mom, and the second 23 is your dad. When these two cells merge, 23 plus 23 equals 46, which is how many chromosomes you have. 46, 23 pairs. Does anybody have any questions? I kind of went through that a little bit fast. Or would like me to repeat something? Is everybody good? Give me a thumbs up if you want chromosomes, or just like the basic idea of what chromosomes are. Okay, no, you guys can use like Zoom reactions. No? Should I go over the slide again? You guys know reactions? Like you can do like go down here. look like this. No, no, okay. Okay, can you hear me now? Can everybody hear me now? Or am I still really quiet? Yes, okay. Is that good? Where did my audio cut out at? Where did I get to? Did I get past like chromosomes and all of that stuff? Or...
Yeah, you got past those that. It just went down for like 20 seconds.
Okay. All right, so this is actually what your chromosome looks like. So this is what is called a karyotype, And they're really special and actually kind of expensive. But basically, you can go into a lab and using a very process that's often pretty expensive. You can produce an image of what your chromosomes look like. So, yeah, if you guys, my visual learners, you can look at this. It's just like they look like. They're all like floating around in your cells. And so this would be a normal karyotype. You see we have two chromosomes in each pair, and there's 23. And the sex chromosomes we call X and Y. And then if you notice on the right, in this image, there are 3 chromosomes in the 21st pair. And this is called a genetic disorder. So, well, you might ask, oh, like, why do they have 3 chromosomes? Well, it could be for a multitude of reasons. For example, sometimes when our cells copy chromosomes, oh, there's an echo. Better, or is this worse?
That has even more of an echo.
Is this better? Okay. Okay. Yeah, they're called sex chromosomes because they decide what sex you are, like girl or boy. Not much, but the 21st chromosome here, there's 3 of them. So this might happen because of a couple of reasons. So sometimes when our cells like divide, remember when I said like there's special cells in everybody that like they have half your chromosomes, and then like when you put it together with like another one, they can form like a kid. I'm not gonna get into that. But sometimes the cells make an oopsies dividing, and they're like, oops, we actually put 24 chromosomes instead of 23. And that would cause a genetic disorder, which can surface usually in growth and development. And they will get tested. Or sometimes, well, like I said, 23 plus 23 makes 46, right? So that forms one cell. But a cell, you're not just one cell. You're made out of like billions of cells. So you're made out of billions of cells. So how do you make so many cells? It's not like a bunch of those like half. No, because something a cell can do is create a copy of itself. So from that original cell of you, you made a bunch more, and that's how you were born, like in the womb. So sometimes you might make an oopsie copying your chromosomes. So for example, a lot of people compare it to like copying a sentence over and over. If I right? Like I love crime and forensics over and over and over for like an entire day. I'm bound to make a mistake somewhere, right? And that's how
If you say
genetic.
banana a million times, you'll end up saying the wrong.
Yeah, that's a good analogy. You're gonna make a mistake somewhere if you're doing it like millions and millions of times. So this specific genetic disorder is something called Down syndrome, and it usually affects some physical traits as well as development. I'm not an expert in it, so I don't know specifically what those characteristics would be. But this is called Down syndrome, and the way that kids usually get identified for this is that the doctor will be like, oh, we think that you had myopathy disorder, and they get a karyotype done just like this, and that would determine if genetic disorder or not. Usually, sometimes though you have to go a bit deeper, and that is what we're going to look at next. All right. So a lot of you have probably heard, oh no, of DNA. DNA. Where does DNA fit into chromosomes? Because I know you all know that DNA is like the instruction manual of your body. Yeah, Anna. Did you have a question, Anna?
No, I just raised my hand to answer the question.
Oh, okay. It was a rhetorical question. So, right. So, but I just said like, oh, chromosomes are determining whatever you're doing. Well, guess what chromosomes are made out of, guys? That's right. It's DNA. So chromosomes are made out of DNA, which stands for deoxyribonucleic acid, very long. So we just shorten it into 3 letters. And it's an instruction manual. So if chromosomes were like the general how-to guide, like maybe like a WikiHow guide, DNA would literally be like the step-by-step, word for word, how to build another one of yourself instruction manual. And DNA basically super big molecule. And it looks like this. I think you've all seen this. And there are a bunch of these. And so these are like, I believe, sugar molecules or some kind of really long molecules. And these little bars attach them. The way they attach them is through different molecules. And these molecules are called. We have 4 bases, usually, in DNA. And they're adenine, cytosine, thymine, guanine. You guys memorize these, by the way. We're not going to go over this. But basically, they're all abbreviated into letters. And they they have you ever seen like DNA sequences? They're like A, C, 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 G, A, C, G. It's really long. It's really, really long. And it's basically how your body has to build itself and how to grow and what to do. Oh. Can you guys hear me still? Hello? Okay. Quiet. Is this better? Yes. Okay. Thank you. I don't know what's going on with my microphone, but yeah, please don't share personal information. But I think I got to here. So like the bases, HTG, and they form like a code. So like you can get your DNA like sequenced, but that also costs like a lot of money, I think. But every human shares 99% of their DNA. So 99% of these bases are going to be the exact same from you and the person sitting next to you. And the other 1%, so just 1% of your DNA is what makes you unique. So when you think about it, there are all kinds of people in the world, you know, there are all kinds like of looks,
What?
you know, of DNA combinations. If there's only 1% that's unique, there must be, the whole DNA sequence must be humongous, which you'd be right, it's literally pages long. You do not want to actually read out a DNA sequence. Okay, so how does this all fit together? We have, the basic unit of life with a cell here. The cell, and in the cell's nucleus, which is where all the DNA is, there are your chromosomes, your X-shaped things. This is one chromosome, and this is another chromosome. They're like joined together. That's a pair of chromosomes. And here's your DNA. Your DNA is like all coiled up into the chromosomes and your different bases. This is like a sugar phosphate backbone. If you remember that the base is attached to one thing. And a gene is just a segment of DNA. It's just a segment of DNA that tells your body anything. And there are ways that we can take DNA and we can like visualize it in another way. And it's through something called gel electrophoresis. I think it's spelled electrophoresis, gel electrophoresis. Okay. And the way that gel electrophoresis is they'll take like a strand of DNA, and DNA has like different like proteins and kind of densities. I don't want to go too much into them because we're not going to really dive too deep into one topic, but basically they'll put it in a gel, and then it's like this big box, and DNA is on one side and it's covered in gel, and then they'll run an electric current through it. And while the DNA will kind of like move into the gel at different speeds, and after a while they will just kind of settle. And that is how we get these like really cool bands where we can kind of visualize a person's DNA. So for example, say they're suspects of a case, and it's like Jenny, Bob, Mike, and Lisa. And we know that the person who done it left a blood sample. So you could sequence that, and you could get this through gel electrophoresis. You would basically color the bands of DNA, and then you just like put it down. And what you do is you match it to whoever is like the closest. So who do you think left this blood out of these? Which one looks the most
Lisa.
similar? Okay, Lisa's a good guess. There's one more. These are kind of hard.
Oh no, not Lisa, Mike.
Yeah, Mike. So if you look here, there's one here, one here. They all match up. And like when you put them side by side, it's really hard to see. But like when you compare them like one by one, you can see, oh, Mike's is basically a perfect replica of the blood sample. So Mike would be who the evidence points to. Okay. And now for the big like grand show, fingerprinting time. Yay. Okay, I hope you guys all have your stuff. If you don't, now's the time to get it. Remember, I'll put this in the chat. We need, okay. Aaron, okay, you need paper, a pencil, and tape. Does everybody have that who wants to do this? Because it's really cool. You get to fingerprint yourself. Paper, pencil, and tape. Everybody who has that, can you guys give me like a yes in the chat if you have it? Once, please don't spam. Hello? Yes. I have 3 out of 4. 3, 4. Do you guys have your stuff, Jaden and Nicole? If you'd like to do this. I mean, if you don't want to fingerprint yourself, even though it is pretty cool, I fingerprinted myself. So, okay. Yeah, Nicole has her stuff. Jaden, do you have your fingerprinting materials? Uh, okay, so either he's getting them or he. I'm just gonna go through the instructions really quickly. Guys, do not start yet. Do not start yet because we still have a little bit of information. But this is just time. So we have a delta. It's like you have ridges on your finger. Thank you guys. And it's like a triangle shape made from ridges on the fingerprint. We'll see a couple types in just a minute. And minutiae, if you don't know, it comes from the word minute. Minute. It just means very small. Like, oh my God. It means really small, like tiny. Like if you look at the single ridges on your finger, I don't know how good you guys see. They're super small. And so minutiae are small details of the ridges in your fingerprint that differentiate one type of fingerprint from another. So for example, like you and another person could have loops, could both have loops, right? They could look pretty similar, but what differentiates it is the minutiae. And some of you might be asking, well, how do fingerprints connect to DNA? And the answer is, I don't know yet. Scientists, it's like a scientific mystery. We don't really know why fingerprints develop differently. We just know that every person has a different fingerprint. And they develop in the womb usually based on different like environmental factors. But we don't have an exact solution yet, which is pretty cool because again, science is still like it's still not finished. You know, we haven't understood everything about the world, including about ourselves. Okay, we're gonna look at a couple different types. Is this working? Well, okay. Jaden, do you have your materials? Uh-oh. Uh-oh. I haven't gotten there yet. Okay. Okay. Yeah. Okay, everybody has their materials. So we have we're gonna just go over 8 types of fingerprints in this class. There are a lot of different names, I know. So we're going to just go over a couple. So here is our first one. It's called the plain arch. Pretty simple. It's an arch. It goes like this. And it's like, there's not really a defined like curve compared to its other version, the tented arch. So in the tented arch, you can see a clear delta here. And it's kind of like closed, right? There's a tented arch and it goes like this. Okay. And the next are 2 kinds of loops. So a loop is, I think you can tell what it means. It's a loop. It goes like this. And the way that we differentiate these 2 kinds of loops are based on whether they point towards your pinky or your thumb. Okay, so obviously that would be different for each hand, right? And my trick for recognizing loops on like paper, because sometimes it's kind of funky to be like, oh, like it's mirrored, blah, blah, blah. Basically, you just figure out what hand it's from. You take your finger and you put it to the paper or like the screen, wherever it is. And you're like, oh yes, that loop points towards my thumb, right? So for example, if this radial loop right here, let's say they told you, oh, it's from your right index finger. I would take my right index finger and I'd be like, okay, I'm gonna put it on here. Okay, yes, it points towards my thumb. So that would be a radial loop. So a radial loop will point to the thumb. Ulnar loop will point towards your pinky, if I'm not mistaken. All right, and then we have whorls. Whorls are just like, they're whorls, like circular, you know? So a plain whorl will just be like this, it's like a bullseye kind of circles. And a central pocket loop is just kind of a type of whorl where it's a loop and there's like a whorl in the middle. If you look at like the ulnar loop and the radial loops, they're not connected here, but a central pocket loop will be connected. The ridges will be connected, like in a circle. And we have a double loop where you have two loops and they kind of form like an S shape. Some people call this an S loop. I mean, an S whorl or an S loop, whatever you want to say. We're going to call it a double loop. And an accidental whorl where you just have so many loops that it just becomes a whorl. We're not going to see these too often just because they're mostly just going to be classified as kind of a plain whorl. But it's a neat little trivia. So we'll put this back up when we are done fingerprinting ourselves. But yes, the big show. Time to fingerprint. Yeah. So on your paper, eat food. Yes. Remember lab safety from last time. Do not eat food while you have graphite on your hand. After class, or I'll give you time if you have time. Immediately go and wash your hands with soap and water. Like make sure every bit of that graphite is off of your fingers, especially before you eat food. Okay. If your fingers are dirty right now, you might want to go wash them as well. But please stay for the instructions. So first step, on your paper, you're going to use your pencil and you're going to shade like a really dark patch. Unfortunately, I don't have. Let's see if I can find a piece. And it's like a little larger than a thumb's fingerprint. So it's going to be like maybe quarter of an inch large. Because here. Here we go. Okay, I have paper and a pencil. Unfortunately, this is a mechanical pencil, but it'll work just. So you're gonna take and you're gonna like shade in a large area. You're gonna make sure the graphite's just covering that paper. So you don't want any like white spots at all. I'm gonna muddle a little bit. You guys don't have to follow me instructions because it's quite a long process. So I'm gonna make it really dark, really dark. Look at that. That's like really dark. It definitely leaves graphite on the paper. And as you're fingerprinting, you can always just like reshade over it. Okay, so what you're gonna do is you're gonna take your first finger, which would be your right thumb. Start with your right thumb and then go through your right fingers and then use your left thumb and go through your left fingers if you have time. And then let it collect the graphite on the finger. You're gonna take your right thumb. I'm gonna put it down here. And you're just gonna like roll it around, basically. Not what I wanted to do. You're gonna kind of roll it around, make sure like the graphite is covering your entire fingerprint, right? I'm gonna do it a little bit. Right. And then you're gonna take a piece of tape and about this big, I don't have tape right now, unfortunately. And you're gonna take the sticky side and put it on your finger, like in your fingerprint, so that the graphite goes onto the tape, okay? And you're gonna press it down firmly, and remove the tape and put it on your paper. Remember to label what finger it was, and then just repeat for as many fingers. Okay, does everybody understand the procedures? Because I want you all to know what you're doing before you actually do it. And remember not to eat food. Hello. Does everybody understand our procedures for this, I guess, met lab? Can you guys hear me actually?
Yeah, I can hear you.
Okay, so can you guys, yeah, you can't eat food right now, sorry. don't eat food right now. You don't want to eat. That's just, it's not a great decision. And I'm not going to. But yes, you guys can get started if you understand the procedures. If you want me to go over anything at all, like if you have a question about anything, just ask because now is the time to do so. And if not, you guys can start fingerprinting. Let me know when you are done with your right hand first, and we'll see how much time you have left. It keeps doing that. And when you guys need like the fingerprint chart, just let me know, and I will. Additionally, I have not posted the homework for this week yet. I will post it tomorrow because if you can't tell, I'm kind of on the road right now. So yeah, I will post the slideshow and homework after class, probably tomorrow morning. I hope it's late. Okay, don't ask me where exactly I am, but I am at a public transport area. Yes. That's why the Wi-Fi is very good. And on another note, I would like to congratulate Suning for being the only one to turn in her homework before it was due. So good job. Remember, everybody, you have to turn it in to actually get the points. I mean, I think I can see your things, but these, yeah, for turning it in. Congrats, bravo. Because you were the only one that turned it in. Yeah. And Also, we should have gone over it last week. So we did brainstorm a lot of the ideas together. So it should. Okay, Seeming is done with her right hand. Do you want to say like what you found, what kind of things you found? I'm gonna screen share the slideshow. Mm. A loop? Okay, that's cool. I mean, I think, don't quote me on this, but I'm like 99% sure loops are the most common fingerprint. I can search up the statistic exactly, but I have all loops. I have all radar loops. Yeah, actually, all earner loops. My bad. But yes, nice. If anybody has like a rare one, like a central pocket loop or a double loop, that would be pretty cool. Okay, here's the picture of our 8. And again, let me know if you guys have any questions or let me know when we're done. I think we're going to start wrapping up at about 50, like 10 till. I don't know what hour it is, but for me, it's like 8:50. Yeah. If you're in Eastern. If you're in Central Time, it would be, I can't calculate this, but it's something like 7, 6. We'll wrap up fingerprinting at around 8:50, and I will do some last announcements and also get you guys to wash your hands. And assuming if you're done with your right hand, you can try doing your left. Okay, let's not share. Let's not share time. Yes, and make sure to clean your hand before you eat food.
I'm done with my right hand.
I'm still here. I don't want you guys to like look at me eating my McNugget. So, yeah, the class is not over. There's 3 different things mine might be. Okay, let's try. And I think Anna's done. Let's try looking at it. If you'd like to turn on your camera, you can, but what ones do you think it looks like? Which ones do you think it looks like?
I think it looks like all of them are owner. Wait a second, let me see.
Are they all loops?
Oh,
Like
yeah, all of them are radio.
radio
loops.
loops. Okay, great. That's good. That's actually I don't quote me on this again, but supposedly, if your fingerprints are like the same, it's supposed to be kind of rare or something. Or that might be like I'm not into statistics if you can't tell. But you have to deal with them. Plain loop, central pocket loop. Okay. So if you look really closely at the central pocket loop, the middle, the ridges connect in a circle. That's a central pocket loop. That's pretty cool. And an accidental whirl, again, it'll connect like this, but it won't be in a loop. It'll just be more like a wonky whirl. And if you're, I don't know if you're talking about a plain whirl or like a loop would just be like this, just curvy, and a whirl would just be concentric circles. It would just be circle after circle. Okay, we have 2 minutes until we're gonna wrap up the activity. That is not the end of class though. Scratch that, 1 minute. So if you guys want to start wrapping up, if you aren't done with your right hand, how to get that done quickly. And if you're on your left hand, you don't have entire left hand. Doing all 10 is a little bit like time consuming. Okay, it is exactly 10 till. So that will conclude fingerprint activity. If you'd like to do more, you can do it after class. But right now, everybody please wrap up. Put, I mean, I guess if you took pencil and pencils out, put them away. Tape, again, put it away. And please go and wash your hands. I'm not sure you want to get like graphite over your computer screen or whatever, or your keyboard. So especially if you're planning on eating after this, go wash your hands with soap and water. And if you're gonna eat, like wash your hands, and then if you wash your hands and then you're gonna eat like a while after, wash your hands again. Just be hygienic. Okay, so I think we have concluded that it is probably a central pocket loop. That's good. I know it's kind of hard to like differentiate at first, but we'll get easier with time, and we're gonna do a lot of practice, especially with like the. It's a lot of just like comparing and contrasting, and I will post the slideshow again after class. That's cool. I've never met a person with a central pocket loop, so now I know somebody, or kind of know somebody that has a central pocket loop fingerprint. That's very nice. Okay. I'm going to quickly go over next week's things. I hope all of you have come back from your hand washing. But next week, we will cover soil tracks and make sure you are completing assignments on Google Classroom. Again, Sunming, good job. You submitted our first week homework, but it is graded. It's 10 points. And it's like, it's not even a school course, but like, I hope you guys like maybe 10 or 15 minutes a week into like just practicing these things, because the course project, yes, we have a course project. We did that last week, the mystery at Manor Hill. You'll have to put all of this together and practice everything and make a final analysis and present to me, the judge, and your mysterious benefactor, who you think the culprit is of Ivy Lancaster's disappearance. Okay, so we're going to do soil tracks and types of soil next week. We're not going to do like a hands-on activity just because I don't want you guys to go out into the world and collect soil. That's kind of weird. We will do some really fun things, and we're going to look at shoes and shoe sizes, and we're going to look at some just statistics, which I have clearly neglected in this lesson. But yes, we're going to end class just a couple minutes early, but thank you everybody. Thank you everybody for coming to class today, and I will hopefully see you next time, hopefully not at another place with bad Wi-Fi. Okay. Bye everybody. You guys are